Functions of several variables. A real-valued function f of x, y, z, or other variables is a rule for creating a new number, which we write f of x, y, z, etc., from the values of a sequence of independent variables x, y, z, etc. Function f is called a real-valued function of two variables if there are two independent variables. It's a real-valued function of three variables if there are three variables, etc. For example, f of x and y equals x minus y is a function of two variables. If we plug in some values, say, for example, x equals 1 and y equals 2, we get 1 minus 2, or negative 1. F of 3 and negative 1 is 3 minus negative 1, or 4. G of x and y equals x squared plus y squared is another function of two variables. Again, if we plug in some numbers, we get g of negative 1 and 2 is negative 1 squared plus 2 squared, or 5. G of 0 and 1 is 0 squared plus 1 squared, or 1. H is a function of three variables, here x, y, and z. H of x, y, and z is x plus y plus xz. If we plug in the numbers 1, 2, and 3, we get 1 plus 2 plus 1 times 3, or 6. If we plug in 2, 4, negative 2, 4, and 1, we get negative 2 plus 4 plus negative 2 times 1, or 0. Here's an example. You own a company that makes two models of speakers, the Ultra Mini and the Big Stack. Your total monthly cost in dollars to make X Ultra Minis and Y Big Stacks is given by C of X and Y, which is equal to 10,000 plus 20X plus 40Y. What is the significance of each term in this formula? Well, if we were to plug in 0, 0 into the function C, it means we make 0 Ultra Minis and 0 Big Stacks. And C of 0, 0 is 10,000. It's the constant term, and in fact, it's the fixed costs. The coefficients in front of the x and the y are the marginal costs for producing each speaker. So it costs $20 to create one Ultra Mini and $40 to create one Big Stack.